Alright, here we go. The next video for you awesome little munchkins. We're going to talk about characteristics of functions. Again, I'm hoping my voice comes through with this, but I really hate to listen to myself on these. So I never go back. Y'all can give me your opinions of whether or not you could hear me very well. Let me know, so on and so forth. Kind of go from there. Anyways, so what's the idea of what we want you to do? Today we want you to understand and utilize characteristics of functions. The main thing is, are you going to be able to tell if it's a function, relation, what type of function is it, domain and range, kind of go from there. These next, don't worry about copying this down right here. I will give you this as a worksheet. So with your first assignment on this, I think this video is going to be able to cover 2 days, but I'm not totally positive, but we'll see. And again, this will be given to you on a worksheet, this part right here. What I do want you to copy down though is what is a one-to-one function, onto function, and both a one-to-one and onto. A one-to-one function means you have one domain, or in the domain, one thing going from the domain to something in the range. But notice there is something in the range that is not paired up to a domain. An onto function, each element, again, same thing, kind of, but notice here you have two domain elements that can go to a one range element. Okay? Both one-to-one and onto, there's exactly one domain to every single little range element. Now these could of course cross, something like that, but that's not, not what they're showing here. And it corresponds, each element of the domain is paired to exactly one element of the range, and each element of the range corresponds to a unique element of the domain. So what they're kind of making note here is this. Both one-to-one, not only is it like this way, it also works that way. Like there's one, this pairs up only to one thing here, the range pairs up to only one thing here, as compared to this range pairing up to two different domains. Okay, so that's a little bit of what those are about. Make sure you copy that down. If you need to pause me. I will be paused. Press the pause button. Oh. Okay, anyways, so you press the pause button, you're now moving on. So let's look at the next part. So what we want to do, the next set is going to be the directions here. State the domain and range of each relation, then determine whether each relation is a function. If it is a function, term it as one-to-one, onto, both, or neither. Excuse the handwriting, hopefully we'll get it better, but this new cover with this new iPad and my styluses, they're having to learn how to get along. Maybe if I have to get a new stylus, we'll see. I don't know. So anyways, if you need to pause me again to copy down these directions, but these are the directions of what you're going to do. So here's our first example. I give you a bubble map. You can see 5 is paired to 3, 6 is paired to -8, and -2 is paired to 1. Now keep in mind, those are the points 5, 3, 6, -8, and -2, 1. Remember, those are points. Don't think about that as an interval notation. And just to kind of go back to something here, when you have something like that where they just give you a bubble map, if you're asking between continuous and discrete, anytime they give you a bubble map or a table or even a set of points, you have to go with discrete. You go with continuous if they give you a graph that shows you connected points, or like a line or a curve or whatever. Okay, so again, what's the domain? Domain is your set of x values. So the way we write that is we would say domain is, and then you use this funky parentheses. The funky parentheses like this, the squiggly parentheses if you want to call it like that, is called set parentheses. When you put it like that, then you're saying there's a set, as in there's a group. Okay? And the group that covers the domain is -2, 5, and 6. They're supposed to be in order from least to greatest, but if you don't put them in order from least to greatest, that is not something I would count off for. Oh, there's the bell. So you heard a bell. Oopsie. See, that will happen sometimes while you're listening to one of these videos. That's okay. Hopefully it doesn't disturb you. If it does, kind of scary. Anyways, the range. Range is the set of all y's. What is that set? -8, 1, and 3. Notice again, I'm putting them in order, not necessarily what they're matched up to. Now, if you notice here, there's only one line going from each domain, so that means it is a function. Okay? If I had seen 2 lines coming from one of the domains, like for example, if I had seen something like that, then that would not be a function. Okay? But this is a function, and it is considered, well, what is it considered? Both. It is one-to-one and onto. And it's one-to-one because, again, one domain paired up to one range only. Onto, or because, again, one range paired up to only one domain. That type of thing. That's why it's both. Again, let's go back to that real quick and see. Why is it both? Okay, the one-to-one, each element of the domain pairs to exactly one unique range. Each element of the range onto corresponds to an element of the domain. So both is saying that for the domain, it only pairs up to one range, and backwards, the range only pairs up to one domain. Okay, so that's what that's doing right there. Okay, next one. Oopsie. Okay, they would probably give you the points here, but I just want you to kind of be able to see the points. Now we can add the points here and say this is -2, 3. This is 4, -1. And this is, these two are 1, 2, and 1, 5. So my domain is going to be, and there's my range. Okay, so my domain is, oopsie, -2, 1, and 4, and my range is -1, 2, 3, and 5. Now you might see a relationship here that is this a function or not? First off, we have what is called a vertical line test. Right there. See how you got points over each other like that? They're on, kind of like they're on top. That means it fails the vertical line test, so it's not a function. But another way you can tell that it's not a function is that, notice here, I have only 3 elements in the domain. I have 4 elements in the range, which means one of those domains had to have, be paired up to 2 different ranges. In this case, the one was paired up to 2 and 5. So that's what makes it not a function. And basically, again, either things are relations or they're functions. Relations are just a group of points, a group of data. Functions are saying that there's a unique domain to the data. And the reason why that's important is because when you identify that as a function, then you can probably find some type of regression that will help you define it, figure it out. And then from there, you can make predictions. Businesses like to do that all the time. So that there is an important reason to this. You're seeing it in a very basic level, but there is an important reason to that. Okay, next one. You can see here the domain. You can see here the range. This is a function. It is onto because each element of the domain. Wait 1 second. Let me give you a simpler definition for this. It's onto because essentially every element of the domain has its own, pairs up to only one y, like to itself. But we also say onto when we notice that there might be, say, y's can repeat, and that's what kind of happens here. So that's why we're kind of going onto. If these two had been different numbers, then it would have been like 1-to-1 or both. Okay, so last thing I want to go over, I know this is kind of making it a little bit longer than I wanted to, but last thing I want to go over is function notation, which is a method for expressing a function in terms of the independent variable. And what that allows us to do, whoops, went too far on that. That allows us to do is, like, say, if I have f of x is equal to 3x minus 5, I am defining f of x as a function in terms of the independent variable x. In other words, x is the number I would put something into, and the output is the y. But instead of using y, I'm using f of x. Anyways, if I want to say, find f of 4, notice that the 4 is in place of the x in the parentheses, which means that I need to put that 4 in place of the x in the equation, or the function, the rule. 3 times 4 is 7, 12. 12 minus 5 is 7. So keep in mind that f of 4 was equal to 7. What that means is this function, you would be able to find a point, or this function, or this graph, whatever, at 4, 7. So there would be a point there. Now obviously this is a straight line, you would be able to know that. But this, remember, this represents the x, this will end up representing the y in an ordered pair. So how would you see it here? Say you have a graph. And I tell you find f of 5 or f of negative 1.5. Well, where is f of 5? Well, you go over to the 5 on the x, so 1, 2, 3, 4, 5, and then find that point on the line. So I'm going over to 5, find that point on the line, there I am, and notice I'm at negative 1, so f of 5 would be equal to negative 1. F of negative 1.5, well, negative 1.5 is between 1 and 2, negative 1 and negative 2, so something like right there. And then that would be at about 4, so I would say f of negative 1.5 is equal to 4. That pretty much covers it for now. If I need to add anything else to it, I will make another video, but otherwise that looks like that should cover it for, say, some characteristics functions that I feel would be very beneficial for you. Thank you so much for your time, and I hope you enjoyed this video. Thank you very much.